All right, today we're going to dive into a classic physics problem that has a surprisingly clever twist. I'm going to show you the standard way to solve it, then a couple of shortcuts, including one that lets you find the answer completely in your head. So let's get right into it.
Okay, so here's the puzzle. A person walks from one end of a 3-meter plank to the other. Now, you'd think they moved 3 meters, right? I mean, it makes sense. Well, it's not quite that simple, and the reason why is what makes this whole thing so cool.
First things first, let's set the stage. This isn't just some plank sitting on the pavement. The conditions here are very, very specific, and they are the absolute key to everything that follows. So here's what we're working with. We've got a 60-kilogram person standing on a 30-kilogram plank that's 3 meters long. And here's the most important detail of all. The plank is on a completely frictionless surface. Think of it like a perfect sheet of ice. It's totally free to slide around. So why doesn't the person just move 3 meters? Well, it all boils down to Newton's third law. For every action, there's an equal and opposite reaction. As the person's feet push backward on the plank to move forward, the plank actually slides backward underneath them. The person moves forward, but the plank slides back. Now, to solve this, we have to talk about something called the center of mass. The easiest way to think about it is as the perfect balance point for the entire system. That's the person and the plank combined. It's the one spot where all their mass is effectively concentrated. And this right here, this is the golden rule for this entire problem. Since the only forces happening are internal, just the person pushing on the plank and the plank pushing back, there are no external horizontal forces. And if there's no net external force, the center of mass of that system cannot move at all. It is absolutely locked in place. That is the key.
Now, you could solve this with some pretty standard, but let's be honest, kind of clunky algebra. Let's just quickly look at what that involves, mainly so we can really appreciate how slick the shortcuts are.
So the traditional method, first you have to calculate the initial position of the center of mass. Then you set up a second, much messier equation for its final position, using a bunch of variables for how far the person moved and how far the plank slid. Then you have to set those two big equations equal to each other and solve. And look, this method works, for sure. But it's a lot of steps, and there are so many places to make a small mistake. Honestly, it feels like using a sledgehammer to crack a nut. There has to be a more elegant way to do this. And thankfully, there is. Okay, let's move on to our first shortcut. This method takes all of that messy algebra and just boils it down to one simple, really beautiful relationship. So, instead of juggling those big complex equations, we can use this direct formula. It says, the mass of the first object times the distance it moves is equal to the mass of the second object times the distance it moves. It's just clean, simple, and direct. When we use that shortcut, we find that the 60-kilogram person moves half the distance that the 30-kilogram plank does. And since their total movement relative to each other is 3 meters, that means the person moves forward just 1 meter while the plank slides back 2 meters. Problem solved way faster. But we can do even better. And now for my absolute favorite part, the method that requires no pen, no paper, and no calculator. This is a pure visualization trick that solves the problem almost instantly. It all comes down to 3 little mental steps. First, you find the center of mass. Second, you imagine a pivot point, an axis, running right through it. And third, you just rotate the entire system, the person and the plank, 180 degrees around that point. So, step 1 is finding that balance point. A quick calculation shows that with our 60-kilogram person and 30-kilogram plank, the center of mass is located just half a meter away from where the person starts. Okay, now just picture this in your mind. The person has to rotate around that point that's half a meter away. So to do that, they first have to walk 0.5 meters just to reach the axis, right? Then, to complete that 180-degree turn, they have to travel another 0.5 meters past the axis. And there it is. Half a meter plus another half a meter, that gives you exactly 1 meter. That's the total distance the person moves relative to the ground. No complicated formulas, just a simple mental rotation. It's brilliant. Okay, let's really see how powerful this trick is. We're going to try it out on a brand new problem with totally different numbers. All right, here's our new challenge. We've got a much heavier person, 120 kilograms, a 40-kilogram plank, and this time it's 8 meters long. The person walks from one end to the other. So,
Take a second, try the mind trick yourself, find that new center of mass, and then just picture that 180-degree rotation in your head. How far does the person actually move this time?
All right, you got an answer in your head? Let's walk through it together. First, we find the new center of mass for this system. Turns out, the balance point is exactly 1 meter away from the person's starting position. So if that axis of rotation is 1 meter away, the person travels 1 meter to get to the axis, and then another 1 meter past it to complete the rotation. And that's a total of 2 meters. Bam! The person moves 2 meters forward, and the 8-meter plank slides back the other 6 meters.
And that's really the power of this method. Once you understand that core principle, that the center of mass doesn't move, you can just bypass all the complicated math and get straight to the answer with a simple mental image.
You know, this really makes you wonder, doesn't it? It proves that sometimes the hardest part of a problem isn't doing the calculation, but finding the right way to look at it in the first place. What other complex challenges out there could be made simple just by finding a new perspective? That's something to think about. Thanks for tuning in.